Number 2, the function f is defined by f of x equals 1.43 to the x plus 0.57, and the function g is defined by g of x equals 14x plus 12 all over x plus 12. The graphs of f and g intersect at the points 1, 2 and a, b as shown in figure 1. Now in part A, let A be the region bounded by the graph of g, the x-axis, the y-axis, and the vertical line 1, as shown in figure 1. Find the area of region R. So that is this region right here. And so we want g of x as our boundary up here, and then we have from 0 to 1. So that's what we're going to do. Now when they say show your steps, that means from 0 to 1 of g of x dx. So when I reach for my calculator, under part 1, this should be g of x from 0 to 1. There we go. And we get an area of 1.513. Now in part B, region R, as described in part A, is the base of a solid. For this solid, each cross-section that is perpendicular to the x-axis is a rectangle whose height is 1/3 times the length of the base in the region. Write but do not evaluate an integral expression that gives the volume of this solid. So we have cross-sections running this way. Those are our bases. So our base is equal to g of x. Our height is 1/3 of that, is 1/3 g of x. And so the area is equal to 1/3 g of x, but that is going to be squared. So to get our volume, we're going to take the integral from 0 to 1 of that area, 1/3. Now you can leave the 1/3 inside or outside the integral, that's not going to matter. But you have to have g of x, quantity squared, dx. And it just says write, but do not evaluate, so we can leave our answer just like that. Part C. A shaded region in figure 1 is bounded by the graphs of f and g on the interval from 0 to x equals a. Find the area of this shaded region. Now here, you can do this one of two ways. You can either define it with two integrals. The first integral from 0 to 1, because notice that this is where these two regions cross. And we have the top function, which is f of x, minus g of x dx. That gives us this region. And then this other region right here is the integral from 1 to a. Now, we still have to figure out where that point is. But now the top and the bottom boundaries switch. So when we subtract, we do the same. Now this is fine, and some people teach it that way. But what's also taught is, to make things easier, just take the absolute value of f of x minus g of x. In this case, it won't matter which one is the top or the bottom. It's going to work out either way. Now we have to figure out where that point A is located, and that's the x value. So when we graph this, here we've got our value. So let's close that folder. So there's our point of intersection right there. So we have to identify that point. And what I did is I just took this point and I just gave it a letter, w. And then I just typed that into the integral from 0 to w of f of x minus g of x inside the absolute value. And that gave us 0.632 as our answer. And this is enough showing our setup for our calculation. Now we probably want to, when we write it down, write down what the value of a, what that top number is. 3.25582. So let's do that. 0.25582. Now, since it was defined as a, you probably could have gotten away with that and not have identified that as long as you got the right answer. I doubt your grader is going to knock you off just for putting that. And part D, let T be the region of the graph bounded by x equals h of y, the y-axis, and the horizontal line y equals 3.5, as shown in the figure. Write, but do not evaluate, an integral expression that gives the volume of the solid generated when the region T is revolved around the y-axis. So now, we're going to make disks. And so this is our radius right here. So, now these disks are going to be stacked in the y direction, so our integral is going to go from 1 to 3.5. Now when we do disk method, pi goes out front, and then our radius is squared, dy. So we're going to write this as 1 times 3.5. Now our radius is that function, h of y, so we're going to square that. Now if you want to put the expression in there, you can, but since h of y and this are equal mathematically, they should give it to you.